All right, so let's recap yesterday. Okay, let's recap. So yesterday, Miss Kane, go ahead and just wrap that up. And we'll, I hope it doesn't say it. Okay, so then turn it in.
Oh. Cameron.
Cameron, I didn't know. Did it really not? Does it really not say?
Unless you exit out. You don't exit out.
Then maybe Cameron, then you and I can just have talk. Okay. Did your heart just sink to your chest just now?
I wrote somewhere.
No, you did. You wrote a lot.
I didn't write nothing.
All right. So yesterday we talked about mass and weight, right? We should be on page 14. So please go ahead and get there. Awesome. Thank you.
It's not done.
That's all right.
What page is it?
14. Mass, volume, weight. Can I please get a volunteer? Well, let's talk yesterday. Okay? So what we talked about yesterday? Mass and weight. Voices should be off. We should be paying attention right over here. Katie, you weren't here yesterday, were you? Mr. Katie, were you here yesterday? Okay. So hopefully you can answer some of these questions as well. All right, River. Say that one more time. What were we talking about?
Mass, gravity, and
Mass. What is mass?
mass is anything that
Shh. What's that?
anything that takes up space and it's like
Could you go write that on the board for me? Oh. Mass. So in your book, expressing weight, mass, and volume. This is on page 15.
Wait, what? She's right.
Right next to mass. Sorry, River, I should have been more specific. Mass is anything that takes up space
How much in the object?
and it's how much of something or how much matter is contained in an object. So mass takes up space.
We write this down.
You are going to have an opportunity to underline it or highlight it in your book.
Well, see, like, when I think of.
You can, but it's also right here in your book. Okay? I'm just having you write that up there. So express weight, mass, and volume. Jordan. Recall that matter is anything that has mass and takes up space. Mass is the amount of matter in an object. Does everything have mass?
Yes.
Do solids have mass?
Yeah.
Liquids?
Yeah.
Gas?
No. Yeah.
How come, Cameron?
Good. We can wait a certain like
instant.
It does. Carbon dioxide, we saw that.
yeah, that's what it was.
We saw that experiment, right? He created carbon dioxide, he poured it into a box, and it weighed more than the air that was inside the box. So in this room, even though we have the oxygen that we have, if we were to get smoke in this room, would it displace that oxygen?
Yeah.
So that demonstrates to us that gases do have mass because at some point we would start to smell the smoke more than we would have healthy air. If we were to close this room down, and every time we exhale, what do we exhale? Carbon dioxide. Eventually, over a long period of time, would we lose all of our oxygen because we're breathing it all in and expelling all of the CO2. So that's demonstration that it has mass. When somebody picked up an object's mass, Katie, Miss Katie?
This,
Oh, go ahead. What's that?
this is mass.
Yep, everything that you have, everything. Liquids, solids, and gases. All states of matter, there's only 3 states of matter, all of them have gas. Or all of them have a mass.
Wait, did it count?
Cameron?
No, I was holding air.
Okay?
I was breathing in my hands.
See, when I was your age, my teacher always said that I held air in my head. I didn't understand what that meant until I was much older.
Means we're good anyway.
Okay.
What?
I get that along.
Held air in my head.
Oh.
Yeah. Alright, somebody go ahead and read that first paragraph, even though I started, read that first paragraph. Volunteer? Chloe. Nice and loud, please.
Recall that matter is anything that has mass in space. Mass is the amount of matter in an object. An object's mass is not changing due to the force of gravity upon the object changes. The amount of space that matter occupies is called its volume. All forms of matter, solids, liquids, and gases have volume. If we want to measure matter, such as figure 1, we can measure both mass and volume.
Okay. So, does the mass of an object change?
No.
No. How come? So, here on Earth versus on Mars, or the moon,
That's Jupiter.
on the moon, does our mass change?
No.
Okay?
Are
Does this stapler have mass?
Yes.
There are staples in the stapler. Not right now. But there are staples in this stapler. Can the mass of this stapler change?
Yeah. Yes.
How does it change, Mr. Caden?
The
The staples, right? So this is a usable resource. So every time this clicks, did it change mass?
Yes.
Albeit small, it changed its mass, right?
Yeah.
Okay? If we were to take something of solid weight, myself or any one of us, and we were all to go to the moon, so long as nobody changed their diets, so long as nobody changed anything,
Our weight changed.
why does our weight change?
They eat a lot.
Nope. Your mass, if we don't change anything, why would your weight change on the moon? Remember?
Because the gravity of the moon differs from the gravity of Earth.
So much. So much. Has anybody ever seen the movie John, I think it's John Carter? It's a Disney movie?
John,
I think it's John,
Coach Carr?
no, I think it's John Carter.
my brother's one.
Okay, so essentially, John Carter is from Earth and he gets shipped over to some foreign planet. The first thing he does when he tries to get up is he pushes off on the ground and it launches him into the air. So what does that tell you about the gravity pull on that planet?
Very, not very.
It's super, super low, right? Because the muscle mass that we have right now, the muscle mass that you have right now, does that muscle mass change? You're used to having the energy here to propel you on this earth, right? So every step you take requires a certain amount of energy, a certain amount of work. For you to do a push-up requires a certain amount of energy, a certain amount of work, right?
That's why it's so hard to work out in space.
Well, right, because you would never. Has anybody seen the Avatar, the first one?
Well, the new one just came out.
Do you remember when the sergeant was sitting inside of the area and he was doing all of those weights?
Yeah.
He had a lot of weight on there because he was trying to build his muscle to help keep him earth fit on a foreign planet. Alright? Weight. Oh, and then volume. So what is volume? It's right there in the book. What is volume? Olivia? Would you mind writing this on the board? Would you mind? And right next to volume. The amount of space that matter occupies is called volume. Is my volume different than Jasmine's?
Yes.
Yes. Is this water bottle different than the book?
Yes.
We only know when we can measure it, right? And this is where geometry comes into play. When you're told to figure out the volume of an object shaped like this versus the object or an object shaped like a table. Is it easy to find the volume of a table?
Yeah.
Yeah.
Length times width times depth. This water bottle. You have the handle, you have the lid, you have the
That's
cap.
so easy.
Right. Miss Gaten's over there going, oh my gosh, that sounds awful. I'm not gonna lie, I thought it was. Do you like geometry?
No.
Okay, so Alex is a big fan himself as well.
It's fun.
Okay? However, I will tell you this is a trick that I never learned until I was in college. Okay? When you have a can and you're trying to find the volume of a can, the most simplistic thing ever is you take your circles, top and bottom, and then imagine that this is you draw a line, so if this is a can of beans or whatever you want it to be, and then you roll that out
That's what more is it?
to a square. Now you have your length times your width, and then you figure this out, put it all together, and that's the volume of that can. I didn't know that until I was in my early 20s.
That's our
So keep that in mind for anybody trying to solve the volume of a can.
that's our old,
Is this? I have no idea. I have no idea until I was in college. Would somebody read weight for me, please? Jasmine.
Weight is a measure of the force of gravity on an object.
Keep going. The whole paragraph, I'm sorry.
The force of gravity depends on the mass of the planet or moon where the object is being weighed. Because the moon has much less mass than Earth. On the moon you would weigh about 1/6 of what you weigh on Earth. Jupiter has more mass than Earth. On Jupiter you would weigh more than twice what you weigh on Earth.
All right, so there's two things in there. Weight. Would you, Jasmine, come up and write what weight is? So what is weight? How is weight measured? Mr. Juan?
What?
How is weight measured? What is weight? So your book, right underneath that yellow highlighted area, where it says weight.
Weight is a measure of the force of gravity on an object.
Just you can write measure of the force of gravity. Okay. So as we've talked about,
Stop.
the moon has more or less gravity pull than Earth. Less? Specifically, and you are going to want to underline or highlight this, specifically how much less. It's right there in that paragraph. Hillary? 1/6. You guys, I promise you will see this again. 100% promise that you will see the difference of gravity from the moon to Earth is 1/6. It's gonna come. Okay? Would somebody read that last paragraph to find the weight of an object? Billy.
Somewhere.
What's that? Yep, no problem.
Yeah.
To find the weight of an object, you could place it on a scale like the one shown in Figure 2. The object's weight pulls down on mechanisms inside the scale. These mechanisms cause beams or springs inside the scale to move. These movements are calibrated in such a way that the object's weight is displayed on the face of the scale.
All right. So let's take a look at this. Bananas on Earth versus bananas on Jupiter. Okay. Effective gravity on weight. Figure 2. On Earth, the bananas on the scale weigh 2 pounds. If you look back up, what is the difference in weight from Jupiter to the Earth?
It says you will weigh nearly twice as much.
Nearly twice as much. Now, does that mean exactly twice as much? It just means nearly, around that 2 times. More than twice. Okay? So more than twice. So is 2.5 more than 2? 2 3/4 more than 2? So they're not exactly sure, they just know that it's more than twice. So what do you notice between the Earth and the weight on Earth and the weight on Jupiter? Explain your answer. Talk for about 30 seconds with your table partner, please. Why are they more? That's good. Eyes back up here, please. Eyes back up. Miss Faith, what the bananas on Earth weigh what, according to the scale in your book? Shh, Jordan. So what is the weight of the scale on Earth? 2 pounds. What do you notice about the weight of them on Jupiter? Roughly. What's that? Less than 5? 4.5 fish, a little more than 4.5? Okay. What's that? They are. So there's another thing. Have you guys ever seen a kitchen scale? Yeah? All right, eyes up here, please. Back table, eyes up here, please. Mr. Caden, Jordan, up here, please. All right, so you have, I'm going to draw the top of it. This is what mine looks like. You got a digital readout right here. You've got, I don't remember where the buttons are. Right here, maybe one in the middle. And there's one that says TARE, T-A-R-E. Does anybody know what that means? What does that mean, Herb? No, it's T-A-R-E. You're thinking T-E-A-R. This is T-A-R-E. Alec, what is TARE? You're setting it at 0. Okay, you set it at 0. Why would it be important to set a scale at 0, Mr. Caden, before you put something on it?
So then you know the true weight of it.
So you know the true weight. Can you get, if you got a piece of dust on here, depending on your scale, could that dust register?
Yes.
Potentially, right, depending on the sensitivity of your scale. So, with scientific instruments, they're a lot more delicate. So if you get something that gets cast on here, you want to push that TARE button, and it's going to set it to 0. Now you're going to take your bananas, your flour, whatever it's going to be, you set it on here. Right, Jordan?
Yeah.
What did I say, Jordan?
I can't remember.
Cameron, what did I say?
You said that you push the care button when you go 0.
So that you can measure something else. So what did he just say, Jordan?
I can't hear.
Okay. What did he say, Juan?
So you gotta set that tear, get a tear button to 0.
Set it to 0. So what did you say, Jordan?
Press the button to set it to 0.
Why do we need to set it to 0? You are looking for specifically 3.25 grams. Why do we need to set that to 0, Jordan?
So we know the true weight.
Could that 1 grain of whatever it was, could that change it to 3.26?
Yeah.
Potentially, right? Depending on the sensitivity of it. So let's switch back over to page 14, connected. It says in the fruit market photo, outline 3 things that have mass. So you are going to, you're going to circle if you want anything on those scales, anything that has mass. Did you almost circle the entire picture? Yep. You can. Because everything has mass, right?
Even the paper has that.
Even the paper, even the page that's printed on has mass.
Or the granite that's on the paper.
Yep. Donuts. When you guys grab donuts with those little sheets, I hope you guys use the little sheets to grab your donuts. If not, okay, take your hood off for me, please. And that's gross. Sample. All right. How much do you think an apple weighs? Write it down. How much do you think an apple weighs?
3.33 pounds.
I have had an apple.
I did this yesterday.
Did we do this one? I didn't think we did one yesterday. It wasn't yesterday. We've done something like it.
No, we did this week.
Okay. How do you think an object's mass relates to? Okay, yep. I'm sorry, we did. My apologies. All right. 16. Volunteer for triple beam balance scale. River, have you read for me yet? Okay. Voices off, please. Triple beam balance scale. Go for it.
A mechanical scale is like a seesaw. An object of unknown weight on one side of the scale
both sides of that. Remember?
The tab isn't being moved onto the other side of the steel.
See, this is where I should have went to Mr. Not Coomer, Mr. Bruner. He's the science teacher at high school. Is that right? Okay. I should have brought one of those scales. So how does, looking at that picture, gentlemen, put your chips away. We're not supposed to be eating chips. Put them away. Eli, please put your chips away. So how do we measure this? How does this fulcrum work? How does this scale specifically work?
Oh, it
Let's
uses
see.
balancing to measure.
Right.
Like at the doctor.
You guys ever been at a, I don't know if this is a thing. I might age myself a little bit. You guys ever played on a teeter-totter, or you might call it a seesaw?
Yeah.
That's how it works. What happens when you get two people of equal size on opposite sides of each other?
You go up and down.
You balance. It eventually starts to balance.
You balance on what?
If the weight of an object has a smaller mass, but the weight is the same weight as something else that might have a larger mass, is a pound to pound.
Yes.
So it doesn't matter if it's 1 pound brick or a pound of feathers, 1 pound is a pound, right? I don't even have a place for you guys, I'm sorry. Get your books put away, thank you very much. And I'm sorry for those of you who got their stuff cut today. I'm ready. Mr. Allen, appreciate you always. That's fine again. Actually, no, I want like this for Williams. Williams. No.
You guys have the Mr. W. That was Mr. That was Mr. That was Mr.
Really? So in Florence, as the elementary kids are walking down the hall, they do the quiet coyote.
Yeah.
So to be cool, was we're going to do the Mr. W.
Yeah.
You know, and the kids, they get to a point, I can't do that. And they do stuff like this. And I said, well, no, that's live long and prosper.
Yeah.
But they tried so hard to